Hi, it's Emma from Arise, and I'm here to answer some questions. I've had a number of people ask me about the iGCSE maths class and if it would be suitable for their child to do and where they just from where their child is and to where the iGCSE maths begins. So I'm hoping just to do a little kind of introduction just to show you the kind of the in-ramp for this class. So this is the textbook we'll be using. I'll show you the cover. It is Mathematics for Edexcel Specification A, International GCSE grading 9 to 1, and it's the Hodder version. But this is that has been endorsed by Edexcel. So let's go down to the table of contents. So the contents that begins, the first chapter is on fractions, decimals, and rounding. And then we go on to ratios and percentages. So it begins with equivalent fractions, how to multiply and divide with fractions, decimals and fractions. So being able to shift between decimals and fractions, what that looks like. Also rounding and approximation, rounding calculator answers. So that would be if you were doing a big sum on a calculator and it had loads of different so it was like 3.4567 blah 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 all the way. How to round that properly. And then something is probably, so this is all likely to be revision. Upper and lower bounds is likely to be new to most people. Then we have ratios and simple percentages. Percentage increase and decrease. So that is things like the interest on a bank account, or if you buy a car, how much it depreciates by. Reverse percentage problems. So that's say you pay so much money for it and it was on discount. How would you work out its original cost? And compound interest. So really real life kind of maths that you would encounter, that every person encounters in their adulting life. And then it goes on to things like powers and ratios. So this is, for example, raised like 2 squared is 2 raised to the power 2, or you could do 2 to the power 3. It's like 2 times 2 times 2. And all the rules involved with these, and it comes on to factors and multiples and primes and things called the highest common factor and lowest common multiple. So HFC, LMC may be new. Powers, people your kids will probably be familiar with squares and square roots or cubing. So this is just raising that to a bit of a higher power. So this is the inroad into it. I am going to do, I'll show you the equivalent fractions just as this would be the first lesson and a little idea how it would be taught so that your child is, so you just see if this is something that your child would find helpful. If I do this and they have no clue, they probably would need to do some kind of key stage 3 maths or find something that would be before iGCSE. But if they're comfortable with this maths I'm going to be talking about just now, then you're probably on the right kind of inroad ramp into this syllabus. Okay. So I'm going to go to this website. This is a PhET website, and it introduces the whole idea of equivalent fractions. So let me start off by let me get my annotation up on this. So let's just think about a fraction to begin with. I've got a circle, and I'm going to split this circle into 4. So we started off with one whole circle, and we've split it up into 4. So this is 4 parts. Now, if I was to colour a part in, we've coloured in 1 part, so that's 1/4, 1 part of the 4, and that's the whole. Okay, let me just get rid of that. And I went rid of annotation because I want to do this here. So here is our whole. And this number here is our 1, so it says 1 whole. If we increase this here, oops, we've now split our whole into 2. So it's 2 parts. Now, if you see, when we did this, let me just put it back down to 1. This went to 1. This went to 6. Actually, let me just, I've been playing with this. Put it down to 4. So 1, this goes to 4. If we do it up to 3, that goes to 6. So this number here is being multiplied. 3 times 2 is 6. 2 times 2 is 4. So let's put some shapes into here. So this little kind of triangular shape in here. So we've now got 1/3 here, 1 part. Now the same size shape is put in here, but that, because this shape has been cut into 2 here, it colours in 2 of the pies. It's the same area of the whole. So 2/6 is the equivalent of 1/3. Let's put some more bits in here. So 2/3 is equivalent of 1, 2, 3, 4/6. So let's bring back our annotation. So we have 2/3 is equal to 4/6. Let's think of another one. I'm going to put this off. Let's clear all this. And let's now do quarters. And let's do 1, 2, 3. So we've got 3/4 is the same as 6/8. But let's change this here. Let's change that to, we can now change it up to 12, 9/12. So let's look at 3/4 to begin with. So we've got our 3/4. If we take this and multiply it by 2, 3 times 2 is 6. 4 times 2 is 8. 6/8, which was what we had here. If we take our 3/4 and this time we multiply it by 3, we get our 9 times 3, 12. So 3/4 is equivalent to 6/8 and it's equivalent to 9/12. And you can do this with anything. So say we do 3/4 and this time we multiply it by 4. We'd have 12. 4 times 4 is 16, 12/16. So this is the whole idea of equivalent fractions. Now, why is this useful? Well, sometimes we get, let me just change what I'm sharing. New share, I want the whiteboard. So, say we have a fraction like 6/10, and we might be asked to write in simplest terms. So this is going the opposite of what we just did. So let's look at 6 and then look at 10. What times table is both 6 and 10 in? Well, they're both multiples of 2. So this time, instead of multiplying, we're going to divide by 2. And what we do to the top number, we have to do to the bottom number. 6 divided by 2 is 3. 10 divided by 2 is 5. So 3/5 is equivalent to 6/10, and this is that fraction in its simplest terms. What about 18/54? So this one here is not, it's not immediately obvious how we're going to get to the simplest form. We can see both of these numbers are even. So this, therefore, if you see two numbers that are even, you can always divide by 2. So let's do that. 18 divided by 2 is 9. 54 divided by 2 is 27. Now this is easier to see that both 9 and 27 are multiples. Multiples meaning they're in the same times table. They're both multiples of 3. So we can divide the top number and the bottom number by 3. So again, what we do to the top, we do to the bottom. 9 divided by 3 is 3. 27 divided by 3 is sorry, is 9. But this is still not in simplest terms because we can divide again by 3. Two divided by 3 is 1. 9 divided by 3 is 3. We could have at this stage divided through by 9 and got straight to here. But sometimes we just don't see that to begin with. It's easier to see these smaller numbers when we looking for the multiples. It doesn't matter. It doesn't matter if you have to do an extra little stage in here. The fact is, what matters is you keep going until you get to the smallest fraction where you can't divide either of these numbers by the same number. They're no longer in the same times table, apart from the 1 times table. Obviously that does not count. So that is finding simplest terms. So I hope that makes sense. And if your child is watching it and they understand this, then this is exactly where the iGCSE maths begins.